Hey guys, so I'm gonna actually go over number 2 here, and then hopefully you can do the rest. If not, send me some questions. We're solving this differential equation. We'd look at it and if we were just solving it, we'd try to do it using separation of variables first. You'd notice that that's kind of difficult. It looks like it's actually a homogeneous equation, right? You could write it as not homogeneous. Sorry, it's not homogeneous. You can't write it as a function of y over x. It doesn't look like, but you could use the integrating factor method because if you just write this as 1 over x times y, then that's your p of x. You move it to the other side and it's in the form that you want. So that's actually how you're going to do part B. Part A is asking us to write the first non-zero terms in the Maclaurin polynomial expansion about y about x equals 1. So remember, the Maclaurin polynomial is basically going to be, I can define y as y of 0 plus y prime. Usually this is like f of x, right? So you might see f of x equals f of 0. It's the same as y, right? Y prime of 0 over 1 factorial times x plus y double prime over 2 factorial times x squared, blah, 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 right? So basically I need to find the derivatives. Our function is dy dx equals 2x plus y over x, which is kind of annoying. They'd give us some initial conditions. They say dy dx equals 1 when x equals 1. Let's just plug that in and see. If I plug in 1, then I get 2 times 1 plus y over 1. That tells me that 1 equals 2 plus y equals negative 1. So it's saying we also now know that when x is 1, y is negative 1, right? So we have the coordinate 1, negative 1, right? Next is we need to find the actual derivatives, right? So what's kind of annoying about this is there's this division. So to get rid of that division and avoid quotient rule, I'm just going to multiply everything by x, right? Because then these will cancel. We'll be left with x dy dx equals 2x squared plus y, right? And then we have a first derivative there, right? We could then take the derivative again. To find, we're going to have to use product rule here. It's going to be 1 times dy dx plus the second derivative times x. The right-hand side would be 4x plus dy dx. Maybe simplify this a little bit, subtract dy dx on both sides, and it will go away. Right, and you get this. And then from there you can go and divide both sides by x, and you get d second derivative is just 4. And that makes the third derivative really easy, right? The third derivative is just 0, and then every other derivative after that was also 0, right? So we can now start taking this information and plugging it into the thing that we want, right? Into our polynomial. Now that I'm thinking about this, I think the book has an error here. I don't think this is supposed to be Maclaurin. I think it's supposed to be Taylor, because Maclaurin's always centered at 0, and this thing's saying center at 1. And so the difference would be you'd be plugging in 1 here, and then you'd be doing x minus 1 for all of these, right? So I'm pretty sure that that's a mistake. It should say Taylor polynomial, right? So then our Taylor polynomial, we need, we basically need y of 1 plus y prime of 1 times x minus 1 plus y double prime of 1 times x minus 1 squared plus y triple prime of 1 x minus 1 to the third. Oh, this is over 2 factorial, this is over 3 factorial, and on and on and on, right? So we have some of this information. We know y of 1, we found that here. When I plug in 1, I get negative 1. Excuse me. So then I need, what's the derivative evaluated at 1? So I'd go here down to this one. I could go up to the original one too. If I plug in, if x is 1, y is negative 1, right? We've figured that out. So if I plug in 1, I get 1 times dy dx equals 2 times 1 minus 1. Which 2, that's just 1, right? So this is, the derivative evaluated at 1 is 1. So I have 1 times x minus 1. Now we need the second derivative evaluated at 1. Here's the second derivative was here. Oh no, the second derivative here is just 4. So this is plus 4 times x minus 1 squared over 2 factorial. And then we can go ahead and rework this a little bit. This is going to be negative 1 plus x minus 1 plus, if you actually factor this out, you get 4x squared minus 8x plus 4 all over 2. So that 2 cancels out. You get 2x squared minus 4x plus 2. These give you negative 2, which are going to cancel that guy. And then if you add this x to this guy, you'll get negative 3x. So you get 2x squared minus 3x, I think. Yes, that is correct. So that's your Taylor polynomial that you've solved for a differential equation. I guess if you want, I can take you through how to find it using the integrating factor method as well. So let's do 2b down here. And we have dy dx equals 2x plus y over x. Remember, for integrating factor, you should have dy dx plus p of x times y equals q of x, right? And so in this case, we would need to move the y piece over. So you have dy dx plus negative 1 over x times y equals 2x. All right. And then what we have to do is we have to calculate the integrating factor, which is always the integral, e to the integral of p of x, where p of x is that thing that next to y. So in this case, it's e to the integral of negative 1 over x dx, which is e to the negative natural log x. You don't need the plus c. We take this integrating factor and we multiply throughout, right? We multiply everything by it. So we get e. Oh, and then before we do that, let's simplify a little bit. I don't want to make that mistake again. This negative is like a negative 1. You could bring it up to the exponent. So that's the same as e ln x to the negative 1. These cancel. You're just left with x to the negative 1, which is the same as 1 over x. Right? So we're going to multiply everything by 1 over x. So 1 over x dy dx plus 1 over x equals 2x. Remember, if this works out, this whole thing should be the derivative of your integrating factor times y, if it works out, right? So we could check, right? If we use product rule, I would take the derivative of y, I get dy dx times the first one, which is 1 over x, plus the derivative of 1 over x, which would be negative 1 over x squared, which is what this is, times y. So yes, that works. And so we know that that's equal to 2x. We then integrate both sides, right? Integral cancels derivative. I'm left with 1 over x times y equals the integral of 2x dx is x squared plus c. If I multiply both sides by x now, then I get y equals x to the third plus cx. We were given an initial condition of the derivative is 1 when x is 1, and we solved that, and we found out before that, so when x is 1, y is negative 1. So our initial condition was 1, negative 1. If I plug that in to find this, then I get to find the c value, then I basically get c is negative 2. Right? If you solve that, c is negative 2. And so we end up with y equals x to the third minus 2x, which should be the same thing we got up here. What did I do wrong? Oh, geez, that was dumb. The integral of x. We should be getting the same thing as we got here. 2x squared minus 3x minus 3x. Hold on one second. Okay, I see where I made my error. Remember when I was multiplying by 1 over x? Maybe you caught this when I was doing it. I didn't multiply the right-hand side by 1 over x. So let me do this in a different color so you can see what I'm doing. I should have been multiplying this side by 1 over x as well, right? Which these x's cancel. and then I'd just be left with 2 here. When I integrate 2, I just get 2x, and so then when I multiply both sides by x, I just get 2x squared. And when I solve this, then this is just 2 times 1 squared, and that gives me -3. And so then this would be y equals 2x squared minus 3x, which I hope that's the same now. Yes, okay. So yeah, it was just a silly mistake of not multiplying by x way back here. All right, so let's say do that. Please reach out if you have questions about any of the other ones on there. Good luck.